What's up, everyone? Steven here with TechMaker. This is part 2 of our VRF with Chainlink little mini series that we're doing here. In the last episode, we kind of started roughing in the actual setup for Chainlink and the VRF stuff that we want to do. And in this episode, we're going to attempt to actually get everything working. Now, as I think I said in the last episode, I've never done this before exactly. So things may or may not work out exactly as we intend. So we'll see what happens here, but let's give it a go. So I think the first thing that it would be prudent to do is just look over at the docs for this VRF one more time really quick. And I just want to point out a couple of things I don't think we mentioned in the last episode. So we have this get random number function, and it takes in this user provided seed, which is just a uint 256. And then we return this bytes 32 request ID. And that's basically a hash, essentially. And we're requiring that we have essentially what this line means is we need to make sure that the contract which addressed this, so this means this contract that I'm inside of, and then address just pulls that address off of it, and then link, we're basically talking to the token, which I guess is declared somewhere else. It's not declared here anywhere that I see. But anyway, it's saying, hey, check that we actually have enough link tokens to actually execute this thing, because we have to have at least a fee. Okay. So then we're returning this request randomness. And what this means, I think, is that, and I haven't even looked at the code for this. I guess we could really quick. Let's look at it in just a second. But the code probably, once we call this request randomness, it probably puts something in a queue, if I have to guess, and then it's going to give us back just a hash, which is a reference to that request. So let's go look at that code really fast. Let me just pull this up. Where can I do this? I don't need this tab anymore. So Chainlink VRF contracts. And I want the GitHub VRF coordinator. I want the consumer base, I think. Yeah. This is a little bit of an older one, I think, but it should be fine. A lot of comments in here. So we have request randomness. It takes in a key hash and a fee. Returns a request ID, and it's internal because we're actually inheriting from this, so it's sort of like we're in the same contract. But if we look here, we have link, transfer, and call, blah blah blah, and then we just return back this make request ID with the key hash and VRF seed. So I've literally never looked at this code before, but I think if I'm just kind of making an educated guess without boring everybody and reading this entire file, I'm assuming this is actually sort of kicking off the main bit of execution. So this is what's going to get us our randomness, I think. Transfer and call would kind of make sense. And it takes the fee. Maybe that's... maybe I'm wrong. Anyway, this little bit back here, so what I think is happening is there's something that's going to happen asynchronously. So it's actually going to go off chain and get the randomness, but it's going to also go ahead and store a request ID so that it knows where to come back to. So long story short, maybe I'm misunderstanding something there, but long story short, we need to actually, shouldn't have gone back there. We need to set this up so that we actually return a bytes 32. So do we need to return? Is it important for us to return a bytes 32 or not? In any case, this request randomness does return a bytes 32. I'm not sure that we have to return it or not. We're going to play around and find out. Because I have some funny ideas that we're kind of doing some like a little bit of Frankenstein stuff right now, actually combining some contracts that probably are not meant to be combined this way, but hey, it's fun, so let's try it out. Just trying to get my head around this a little bit more with you before we go do anything too crazy. So we may hit some roadblocks, but we'll cross that bridge when we get there. So the first thing I want to do is I'm going to go actually and pull up the Open Zeppelin transfer function. So ERC20 functions have to have a transfer function. ERC20 tokens have a transfer function built in, and this is what it looks like. Okay. So first of all, just a note, if this all seems crazy and foreign to you, there are definitely some like slightly more basic Solidity tutorials out there. I'm mostly just doing this as sort of like I want to learn this, and I felt like it might be interesting to work through with you. So anyway, okay. So first question, can I return something else here? Like if I do like bytes 32 and like don't comment this out, and go ahead and comment that out, like, or like if I do bytes 32, well, what's the error here? Overriding function return types differ. So I can't return anything except a Boolean here. And that's because I think the ERC20 thing, the parent contract returns a Boolean. So you're not allowed to actually return something different, is what I'm thinking. Again, I come from like a more dynamic programming language background. So this strongly typed stuff is, even though I've been doing this for a little bit, it's a little strange to me. So, okay, so I've got to return a Boolean. What I'm wondering is if I can take this transfer and put that down here and fulfill randomness, and basically have that execute the transfer. And then up here, request randomness. So the idea would be to go ahead and request randomness, which is going to kick off the Chainlink interaction, and then use the results of that randomness to actually send some money to somebody. So we're going to send, theoretically, a random amount of tokens. So it could be used in like a game, potentially, is sort of what I have in my head. If this doesn't work, we could write our own function called like funny transfer. But that's a little bit less cool, because the way I'm envisioning it is like in your MetaMask, you could actually go to send somebody some tokens and then they get a totally different amount of tokens. I mean, this is not useful. It's just funny. So just to be clear, at least to me, it's funny. Maybe to you, it's not funny and it's ridiculous, but whatever. It's my video. So anyway, what we need to do is we obviously need to give this the key hash, and we need to give this the fee. And then the seed, what I want to do is use the amount as the seed, which kind of works out nicely because the amount is actually a uint256 in both places, so I don't have to do anything funny there. So that's basically it, except what we need to do here is capture this somehow. So we need to say request ID equals that, which should be fine because we actually are capturing, how can I say this? Like, so what's happening when we call request randomness over on the VRF consumer base parent, which we looked at over there, we're getting back a bytes 32 request ID. And again, this is a little bit complicated, but we're getting this. Like it's running this return make request ID. So when we call request randomness, this is what we get back. And then somewhere, I mean, I could be wrong about the exact sort of execution order here because I haven't read all the code that supports this. But what I understand is happening is the actual randomness gets generated offline or off chain. We get this ID back so that we know how to reference the request. And then the Chainlink code is going to call fulfill randomness at some point in the future. Okay, so, and again, like we're actually obviously not writing tests right now. And that's because I've never done this before, as I've said a couple of times. So I kind of decided to set the TDD thing aside until I get a better idea. I think when we get into the actual NFT project, which be sure to subscribe to the channel if you want to get updates for when that starts coming out. But once we get into that, I probably will do more TDD. But right now, I just don't really fully understand how this is all put together. So I want to just kind of work through it. So that's what we're doing. Okay, so we're getting back to this request ID. So what I want to be able to do. So what happens when we call message.sender? So here you see this thing. We have transfer message sender. This seems to me that this is probably a fancy way that they've done to basically just call so there's this thing, if you're not familiar with Solidity, whenever you execute a function, you have to basically execute that from your wallet or you have to have an unlocked account somewhere or whatever. And Ethereum can tell which address executed that. So you have this message.sender thing that you can always call to figure out who executed it. So that gives you some ability to do security and so on. So we've already done that up here, and I don't know if I called that out when we went through it, but this is whoever actually generated the transaction. So your wallet address, essentially, if you're the executor. Okay, so right here, the message.sender will be Chainlink because they're calling back in. One of their contracts is going to call back into this contract. So or something like that. Yeah, it's going to be something from them. So we can't use message.sender here. We need to look up the recipient, or we need to look up the sender and the recipient. So we need to have address sender equals something, and we need to have address recipient equals something. And then we need to pass in here transfer sender, transfer, and then have recipient. And then we need to also calculate UNT 256 amount equals, and this is going to be where we use the randomness. Okay, so obviously this is just a little filler code for the moment, but we need to figure out how do we get the sender, how do we get the recipient, and I believe we'll be able to use this request ID to do it. So let's think about how we can do that for a second. So Solidity has this capability to store something called a mapping. So up here at the top, we're declaring these sort of like contract-wide variables. And we can declare something called a mapping, which is essentially like one type of data that points at another type of data. So like if you're familiar with arrays from other languages, you could have something like a UNT 256, which would just be like an index that points at like an address or something like that. This isn't really going to work for us because what we want to do is store the actual ID that comes back from Chainlink. And so we want to create a mapping. I kind of made a bad example there. It's not this is not an array. You could mimic an array like this. It's more like a dictionary from Python or something like that, or a key value store where you have like one thing points at another thing, but you can kind of use anything, as far as I understand it, to map to anything else. So we can do bytes 32 here. And now we're pointing at an address, but we actually need to point at an array of addresses, if that's possible. Because we need to store both the sender and the receiver. So the way I'm thinking about it, what's wrong with my constructor now? Oh, because I didn't put a semicolon after that. Let's see if that blows up. Unexpected identifier. Oh, it's because I didn't give it a name. Okay, so what do we want to call this? We want to call this, I guess we could call it transactions, maybe. Is that going to give me any problems? It looks like it's not. So what I'm thinking I can do is, and I think you could actually formalize this more in like, let me not get sidetracked here. Maybe that we can do more stuff on data structures later. Hopefully I didn't explain that too badly. If you get confused, look up mappings and Solidity. Somebody out there is bound to have written a great article about it or created a great video about it. What I want to do is say transactions, and then with the request ID. So that's letting me basically reference a specific request, And then I'm going to set set a couple of addresses in here. So I'm going to put it equal to an array. The first thing is going to be message.sender, which is the person who actually executed this call. And then I'm going to do recipient as the second argument. And so basically what this has set me up to do is say, okay, we've got the request ID. That's gonna kick off the Chainlink deal. We've got that bytes32 hash, and I'm basically creating a new record inside of this mapping for a transaction, and I'm setting the first argument to the sender who's executing the transaction and the second argument to the person who's supposed to receive it. Okay, so that means that down here what we can do is say well, what do we want to reference this as? So we have the address array basically equals, and we can call this like transaction equals the transactions, and then pass in the request ID. And so that's going to let us look up our transaction. And then the sender could be transaction 0. And then because that's going to basically get the first element out of that array. The recipient could be transaction 1. And that's going to be the second thing out of there. Let's comment this out for a second, just see if, so we have an undefined thing for amount, but the rest of this looks okay. Okay, so the amount is really kind of now the secret sauce of our funny token here. So what I want to do is say uint 256 amount, and I haven't actually even written this down anywhere, so we're just going to make it up right now. So randomness basically is the random number coming back from Chainlink, and this number could be giant. So how to use this, I mean, you can do different things with it, but let's go over to the terminal really quick. So this is a whole side deal, but I'm going to open up a Ruby terminal here. Hold on, let me clear this out. So basically I'm going to use a modulus to essentially get like a smaller number. Like let's say you want to get a number between 1 and 100. Like if I've got a whole bunch of numbers, and then I do modulus 100. So that's basically going to give me a number between 1 and 100. And actually that might be 0 and 99. So you could do plus 1 at the end. And that's going to give you like, between 1 and 100. So if you're not familiar with a modulus, basically it's a remainder. So let's say that I've got 4 modulus 2. 2 divides into 4 twice, obviously, so the remainder is 0. If I do 5, I'm going to get a remainder of 1, so on and so forth. If I do 5 modulus 3, I should get 2. So anyway, if it's kind of basic stuff, but we're going to use it to basically just take whatever number we get, and I want to get a number between 1 and 100. So we're going to do a modulus for that back over in Solidity. Okay, so let's go back over here to the code. And what I'm going to do, let's break this up just a little bit. So I think we could do uint, I don't know how big I need this to be. Let's just say uint 16, and we'll say percent of stack equals, and I'm going to take the randomness mod 100, kind of like I was doing over there, and then add 1 like so. So that's going to let me essentially get a percentage of the person's stack that we're actually going to send. So I'm thinking like we don't really worry about the amount you're trying to send. We just say we're going to take some random percentage of your stack and send it to the other person. So that's kind of funny. So the next thing I need to do is get uint 256 and say sender balance, and we'll say balance of, because that's part of the ERC20 contract that we're actually in. So we should be able to say balance of sender like that. And now what I want to do is actually crunch the number to get the amount of tokens we want to send. So to do that, basically what I'm going to do is say sender. So, didn't mean to do that. So just to kind of clarify where this math is coming from that we're about to do here, like you can think of the percent of stack as like, okay, let's get back to number 57. So the fraction of the stack is 57 divided by 100. So what I need to do is say percent of stack times sender balance, and then divided by 100. Make sense? Okay, and what do I got going on here? Data location must be storage memory, address memory. Does that make sense? uint percent of stack. So I need to keep that as 256, I guess, because I'm multiplying some 256s. Okay. I think that all looks good. I mean, it's not obviously broken anywhere. Okay, so I guess one thing we could do is just go ahead and deploy this thing and start playing with it and see what happens. I think I'm going to kick that into one more episode because I want to just kind of review this before I go ahead and deploy it. And we also need to go through some steps to get like some Rinkeby Chainlink and fund this deal and whatever. And I may actually run some of the tasks here through the testing. So let's see about that. The tests are all going to be broken now though, because this doesn't work like a regular ERC20 token anymore. So I need to think on a couple of things. I'm going to pause here, and in the next video, we're going to test this out and see if it really works. And part 3 should be online at the same time as this one, so it should just be like, you know, right in the playlist or in the suggested videos or whatever. So it should already be there. But anyway, I'll talk to you in the next episode. Thanks for watching.